is 2022 AMC 10B problem number 20. Let ABCD be a rhombus with angle ADC equaling 46 degrees. Let E be the midpoint of CD, and let F be the point on BE such that AF is perpendicular to BE. What is the degree measure of BFC? Okay, so let's try to make a rough sketch of this diagram. And if you're wondering why I'm making the diagram so small, particularly with a big space under here, we'll find that out very soon. So E, that's that midpoint, C, D, A. And now we draw a 90-degree angle to here. Okay, and this is the angle in question, BFC. Okay, so how do we find this angle? Well, the reason why this problem is so tricky is because if it was asking us, for example, for like an angle that was based off of the points A, B, F, E, and D, that would probably make things a lot easier because the diagram was drawn based off of BE and AF, which is perpendicular to BE. And now we're just connecting C to that point F and just trying to find the angle of that weird angle that's formed. That almost seems like it wouldn't be a whole number value, but it is. And the reason for this is because we need to find a way to connect BE, the fact that this midpoint thing, right? The fact that's connected to this midpoint here, we need to connect that to the fact that AF is perpendicular to BE. So you have to find a way to connect this right angle and these two equal segments. And well, whenever we have like a midpoint thing like that, it might be helpful to extend it. And the reason why it might be helpful to extend it here in particular is because it gives us a lot of equal lengths to work with. So we extend it to side AD, and let's call this intersection point G, right? Well, what other equal lengths do we have now? Okay, so first off, we have these two lengths are equal, but also because it's a rhombus, this is equal to this is equal to this. So I'm going to erase these actually. Yep. So AD is equal to DC is equal to DG. And the reason for that, well, is just because these two are equal, right? As we've already talked about. And the fact that these are parallel and that we're connecting it via this way means that the two triangles, basically BEC is similar to GED. These two triangles are similar to each other. And because we know that DE equals EC, that actually tells us even more specific than similarity. They're actually congruent triangles. So they're congruent triangles, which implies that BC is equal to DG, which gives us everything we need to know because the BC is equal to DG and BC is equal to AD is equal to DC because it's a rhombus. All the side lengths are equal. And the reason why this is extremely important is because that means that D, if we draw a circle with radius DA centered at D, it would pass through A, C, and G. But not only that, it would also pass through F. And the reason for that is this 90-degree angle here. And this is exactly what I was talking about. We are trying to use the midpoint information to connect it to this right angle here. So let me just move the right angle over here, right? This right angle is a right angle in this triangle here, right angled triangle AFG that we've just formed, and it has hypotenuse AG. And this relates to Thales theorem, right? And basically by Thales theorem, because we have AG as the diameter of this circle we're drawing, like if we drew this imaginary circle here, it would have to pass through F. Like this imaginary circle. This is a very poorly drawn circle, but you get the point. This is supposed to be the diameter of the circle, right? And with this radius here, dA, I could try to draw a more precise circle, but that might be a little difficult. Let me just. Yeah, it's a bit difficult to draw it, but I could try just to give a better feel for it. Yeah, so this doesn't exactly pass through the 3 points as planned, but it's close enough. Yeah. Basically, the point is that if we drew our hypothetical circle, it would pass through A, F, C, and G. Let me just redraw that. Let me try to draw it a little bit better though. Yeah. Doesn't exactly line up because this diagram isn't exactly perfect. Has like a little bit of a imperfection, but that's not the point. The point is that A, F, C, and G are cyclic, meaning that they all lie on this circle because this is a right angle here, and it's a right angle opposite this hypotenuse, which is also the diameter. So by Thales' theorem, it's on the circle. And now this basically solves the problem because by our theorem of like arc length, right? We know that because this angle GAC right here, right? What is that angle equal to? Well, we know that ADC is 46, which means that DAB is 134, right? Which means that since we're bisecting this angle here, right? DAC is half of that, which is 67. DAC is 67 degrees. Yeah, and what that means is that the arc length of GC here is twice that, which is just 134 again, right? And then we use the arc theorem. Well, now we can find what angle GFC is. What angle GFC is, well, it's 67. We take half again. We get 67, and now we're very close because GFC is 180 minus the angle we're looking for. So our answer would just be 180 minus 67 is equal to 113. Choice D.